So guys, we are back with type 3. So if you have watched my previous two videos on this method of substitution, you must have already realized the key concept involved here. So the key thing involved here is this idea of substitution. So you solve one of the equation, or I should say we should try to solve one of the equations for a particular variable, one of the variables, and then substitute that in the second equation, simplify, solve for that variable, and then substitute back and solve for the other one. So that is the basic idea, right? In this case, the type, which I like to call as type 3, first, none of the variables is solved for, and the other thing is like all these variables on the left hand side have coefficients different than 1, okay? So the first thing is still, the key thing is still to keep in mind that we want to solve for one of the variables and then go from there. So in this case, guys, again, there's two equations, so we are free to use any one equation and solve for any one variable that we like, but it makes sense to use a variable or use an equation, rather use an equation which is easier to work with, so that we can isolate one particular variable and then use that for in the second one. If I look at both these equations carefully, in equation 2, the coefficients are 3 and 5 here, and then there's an 11 on the right hand side. So if I look at these numbers 3, 5 and 11, I can see that they are not divisible by a common number, right? But if I look at this number 1, I have 2, 4 and 10, and right away I can see that they're all divisible by 2. And once I divide them by 2, which I'm allowed to do mathematically because I'm dividing everything or both sides by 2, we can get rid of this 2 right away, and then I'm left with just an m with an invisible 1. And then from there we could just simply solve for that m and then use the other method of like substituting, right? So let us go ahead and try to do that. But guys, that is the idea. Before we actually start working on the system of equations, we have to spend 30 seconds or a minute looking at both the equations and asking ourselves which one of the two equations is easier to work with. Once we have figured that out, then we should start working on the example, okay? So for equation 1, what I'm going to do is, again, there's more than one ways of isolating or getting rid of this 2 here. What I'm going to do here is I'm going to divide both sides by 2. That's like one of the easiest way of getting rid of the 2. So I will write that step for you here. So 2m plus 4n equals to 10, and I'm dividing both sides by 2. So I have to divide this by 2, the second term by 2, and the right hand side by 2 as well. So whatever we do to one side, we have to do the same thing to the other side, and we also have to do the same thing to each and every term. This crosses out. I have m equals to 2n, sorry, there's a plus here, m plus 2n equals to 5. And from here, we want to get m by itself. Guys, if you want to get n by itself, that is also equally correct, but it would be a little bit complicated to get n by itself, because then you will have to again divide everything by 2. And 5 here is not divisible, it's not perfectly divisible by 2. So you will get a decimal. Can you still do that and use it to substitute and get the final solution? Yes, you can, but it's still going to be a little bit more complicated. So I would rather simplify or solve this for m than for n. So to solving for m, it's simply subtracting 2n from both sides. So I get m equals to 5 minus 2n. So I have first equation transformed into this one by dividing both sides by 2, right? And then from here I solve for m. I have m equals to 5 minus 2n. From here you already know what to do. You use this equation and substitute that back in equation 2. So it's going to be 3, and then m will be replaced by 5 minus 2n, but you have to keep in parentheses, it is a binomial. 5 minus 2n, and then what do I have? Then I have plus 5n equals to 11, right? From here you distribute this 3 and we'll be able to solve for n. So it's 15 minus 6n plus 5n equals to 11. Simplifying further, combining like terms, this and this adds up to negative n equals to 11. Guys, there's an invisible 1 here which we do not really need to write. And then to get that n by itself, we have to first what? Subtract 15 from both sides. And this crosses out. I have negative n equals to 11 minus 15 is negative 4. I have these both negatives on the both sides, so you can just basically either just cross them out right away, or you can think of dividing both sides by negative 1. In both the cases, this will cross out, and I'll have n equals to 4. That is my value for n. Once I have my value for n, then I should be able to find the value for the other variable, which in this case is m. Again, from here, guys, you can go back to equation 1 or equation 2, substitute the value for n equals to 4 and try to solve for m. Or if we look carefully, and as I like to say, keep our eyes really open, we can actually use this n and substitute in this equation right here, because this is already solved for m. So it's going to be much easier, and we can save some time by actually using this equation rather than using any of those two equations. Guys, once you are very confident with these things and you have done it like so many times, you can substitute this back in any of the equations, and you should still be able to do it rather quickly. But for now, I'm going to use this one, and it makes more sense to use this one because we have already done the work for this, right? We have already solved for m. So using this equation, let's see what we have. We have m equals to 5 minus 2 times n, which is 4. So it is 5 times 2 times 4 is 8, which is negative 3. That is the value for m. And we like to, as you already know from my previous videos, that we like to write the final solution as a coordinate pair. So m comes first and n comes next. So it is m first, which is negative 3, and then n, which is 4. Guys, this is the solution for this system of equations. And the last step is to verify. And for this particular example, I would like you guys to actually verify that on your own and see if this actually is the solution for both the equations. So from my previous videos, you already know how to do the verification piece. Make sure that you verify it for both the equations, not just one. We have to verify it on both. Okay, guys, that ends the substitution method for now for a rather simple linear system. And then next I'm going to talk about again system of equations, but we are going to use the elimination method. And let's see if we break it down into probably 3 types as well. And once we do this, then we can talk about some non-linear examples as well. Okay, till then, guys, practice more examples based on similar to the system of equations, and you will get more confident with these. Okay, if you have any questions about system of equations, please feel free to give me your feedback or ask me, and then we can go from there. Okay, thank you.